Studying how to write numbers in the powers of 10 gives us the jumping off point to study scientific notation, which is what comes next. So for today, we're going to focus only on powers of 10, which is to say how can we write numbers using a multiplication problem and the number 10. Well, when I see a number like 3,200, I can immediately think of, well, it's 32 times 100, right? 3,200 is one of the ways we say this. And I could then change that to 32 times 10 times 10. That would be an example of writing it with powers of 10. I could clean this part up and write 32 times 10 to the second, or I could even change the 32 into 3.2, and then I get an extra 10, right? Basically, I've decreased this by a 10, so I'm going to increase this by a 10. So I get 3.2 times 10 to the third. And while this one and this one are both writing it in powers of 10, this one at the bottom probably makes us the most happy. With that in mind, we can also write small numbers using powers of 10 as well. Same concept. Let's see if we can just write it in some way, right? In the previous one, I wrote 32 times 100. In this one, I'm going to write 4 times 1/100th. So 4 times 1/100th. Now that's not a power of 10, but I can make it into something that involves tens. So I'm getting there. I could take the 1/10 and change it into 10 to the negative 1, which is the same thing. And then I can use some of my exponent rules to combine same bases where I add the exponent. So negative 1 and negative 1 make negative 2. And once again, while I have 3 different examples of powers of 10, the last one is the one that makes me happiest. So we have 2 good examples that you could use to rewrite numbers in powers of 10. Now, if we can write numbers in powers of 10, we should be able to look at numbers written in powers of 10 and decide which one's bigger and smaller. And you have 2 different strategies here. Your first strategy is the most work, but some of you are going to like this one. It is simply multiply it out, right? So I have 3 times 10, and there's 2 of them. So 3 times 10 times 10. So 3 times 10 is 30, times 10 is 300. So that's not that bad. And over here I have 2 times 10 times 10. So 3 times 10 times 10, 2 times 10 times 10 is 200. So I have identified that my first number is larger than the other. So multiplying it out is simply an easy strategy. Now, what sometimes happens, and I had intended this to be the case, but I changed my example before I recorded, was what happens if I have a different exponent? If I have a different exponent, and you can still multiply it out like I did in purple, but that's going to give you an extra 10 over here, that's going to give you an extra 0, and it's going to change your answer. Right, so now all of a sudden with a modified question, the 3 makes that second number bigger, which leads us to our second strategy. Our second strategy isn't multiplying it out, which seems a little barbaric. It is just look at the exponents, right? The larger exponent is the larger number. So now all of a sudden with no math work at all, I just have to look. 3 is bigger than 2, so the second number is bigger than the first. Now, if there's a tie, like they're both the same, then you go ahead and look at the first number and make that your tiebreaker. But there's 2 strategies for deciding which number is bigger or smaller. And then ultimately, if we know which number is bigger and smaller, we might ask the follow-up question, how many times bigger or smaller is it? For example, like how many times bigger is Jupiter than the Earth? How many Earths could fit into Jupiter, for example? So if that were the case, or any other scenario like that, we might have 2 numbers, and we want to find out how many times bigger one is than the other. Well, the problem may not even tell us which one's bigger. So the previous technique of looking at the exponents and deciding which one's bigger and smaller helps us out a lot right here. So I see that the 5 is bigger than the 2. So our first number is quite a bit bigger than our second, right? Here's our bigger number. And the second piece that I want you to take away from this is what you're actually being asked to do. If I take the smaller value and I multiply it by some multiplier, I get the bigger number. And what we're after is, what is that multiplier, right? How many times bigger? Multiplication. How many times bigger is the bigger one than the smaller one? So I'm going to use a little bit of some algebra skill here that I know you probably have. I'm going to divide both sides by the smaller number. Now, I don't know what that smaller number is going to be, and it's going to change based on the questions, but look how the smaller numbers on the one side completely cancel out. And on the iPad, canceling out sounds a lot like erasing. So look what I get. I get the question mark, or the thing I'm after, being the bigger number divided by the smaller number. So let's do that. let's just take the bigger number, divide it by the smaller number, and now let's finish the problem. Watch how easy this is going to be. Oh, I'll leave that there. I'm going to divide the numeric part first. 8 divided by 4. 4 goes into 8 2 times, so there we go. Now I'm going to go ahead and use the exponent rules. I'll just highlight in a different color. I'm going to use the exponent rules for the second piece. Those exponent rules are just subtract. So I'm going to take the top exponent, 5, minus the bottom exponent, 2. And I'm going to get 5 minus 2 is 3. And if my goal is to figure out how many times bigger the big one is than the small one, I've done that. I have a number in scientific notation. And while this isn't a lesson on scientific notation, if you want to take that number that's written as a power of 10 and turn it into a regular number, we simply do 2. Where is it? 2 times 10 times 10 times 10. I do it 3 times because of the 3. That's 20, 200, and then 2,000. So 2 different ways to write your answer. One as a power of 10 on top, below it as the evaluated version, and we've calculated how many times bigger one is than the other.